Good morning and welcome to the Royal Swedish Academy of Sciences and this press conference about the Nobel Prize in Physics. It's good to see all of you here today. And I will also internet or on TV. I'm Göran Hansen. I'm the Secretary General of the Academy. And with me today I have two members of the Nobel Committee for Physics. On my right, Professor Tors Hans Hansson, who is the chairman of the committee. And on my left, Professor John Wettlaufer, who is also a member of the committee.
そしてウルフ委員にいらしていただきます。今朝、選考委員会は会合を行い、物理学賞を決めました。そして受賞者にも連絡を取りました。まず、スウェーデン語で発表します。そしてその後で、英語で発表します。そして、ハンソン教授とウトラフ教授が説明します。
2021 års Nobelpris i fysik för banbrytande bidrag till vår förståelse av komplexa fysikaliska system. Den ena hälften av priset utdelas gemensamt till Shukuro Manabe och Klaus Hasselmann för fysikalisk modellering av jordens klimat, kvantitativ analys av variationer och tillförlitlig förutsägelse av global uppvärmning. Den andra hälften av priset går till Giorgio Parisi för upptäckten av hur oordning och fluktuationer samverkar i fysikaliska system från atomära till planetära skalor. The Royal Swedish Academy of Sciences has today decided to award the 2021 Nobel Prize in Physics for groundbreaking contributions to our understanding of complex physical systems.
複雑な物理学の理解に貢献した人に贈ります。共同受賞者は真鍋淑郎さん、クラウス・ハッセルマンさん。地球の気候のモデルを作りました。そして地球温暖化の予測に役立ちました。もう一つはジョルジオ・パリージ氏。複雑系をさまざまな分野で説明されました。
Eine Hälfte geht gemeinsam an Shukuro Manabe und Klaus Hasselmann für das physikalische Modellieren des Klimas der Erde, die quantitative Analyse von Variationen und die zuverlässige Vorhersage der Erderwärmung. Die andere Hälfte geht an Giorgio Parisi für die Entdeckung, wie das Zusammenspiel von Unordnung und Fluktuationen physikalische Systeme von der atomaren bis hin zur planetarischen Ebene bestimmt. L'Académie royale des sciences de Suède a décidé ce jour d'attribuer le prix Nobel de physique 2021 avec une moitié conjointement à Shukuro Manabe et Klaus Hasselmann pour la modélisation physique du climat de la Terre, l'analyse quantitative des variations et la prédiction fiable du réchauffement climatique. Et l'autre moitié à Giorgio Parisi pour la découverte de comment le désordre et les fluctuations interagissent dans les systèmes physiques d'échelle atomique à planétaire. Koroliewska Akademia Nauk решила сегодня присудить Нобелевскую премию по физике одну половину Порвну Shukuro Manabe и Klaus Hasselmann за физическое моделирование климата Земли, количественный анализ вариаций и надежный прогноз глобального потепления. А вторую половину Giorgio Parisi за открытие того, как беспорядок и флуктуации взаимодействуют в физических системах от атомных до планетарных масштабов. And you see the new Nobel laureates on the screen above us.
スクリーンに受賞者の写真をご覧いただいています。 簡単なデータですけれども、真鍋淑郎さん、1931年生まれです。日本の新郷で生まれました。東京大学で博士号を獲得し、その後、プリンストン大学で気象学者をしていらっしゃいました。クラウス・ハッセルマンさんはドイツのハンブルク生まれ、1931年生まれです。ガッティンガムの大学で博士号を獲得し、今はハンブルクのジョージ・プランク研究所で仕事をしていらっしゃいます。ジョージ・パリージさん、イタリアで1948年に生まれました。ローマ・ラ・サピエンツァ大学で学士号を取り、その後大学でずっと教えていらっしゃいます。では、ハンソン教授に説明していただきたいと思います。皆さんは物理学は単純で分かりやすい現象についてのものだけだと思われるかもしれません。例えば、この太陽の軌道、地球が回っている、そしてこの原子の結晶、非常に分かりやすい、そしてこの電気自動車から電球までです。でも、物理学ははるかにそれよりも深いものなのです。物理学の基本的な仕事というのは、基本的な物質を使って複雑な技術を説明しようとします。例えば、素材がどのような構造なのか、そしてこの地球の気候はどのようにして生まれるのか、これは何が必須であるのかを示しています。また、数学の能力も必要となります。今年の受賞者は本当にその達人なのです。ウェット・ラウファー教授に聞きます。遠くから見ると、複雑な物理学の現象というのは単純に見えます。原子から惑星までよく見ると常に構造が明らかになります。私たちは複雑さにあふれています。あらゆる規模においてです。科学者はこう尋ねます。どのくらいの詳細がこうした観察を説明するために必要なのだろうか。我々はすべての水の分子を追跡しなければ海洋は説明できないのだろうか。どのような規模が重要なのか。どのような現象がこうしたシステムから生まれるのを知るためにはです。今年の賞の半分は地球の気候の物理学に注目しています。これは物理学の古い話題なのです。1824年に始まりました。フリエは地球の大気は太陽の放射線から透明であることを発見しました。しかし
ではここで改めてお伝えします。今年のノーベル物理学賞にアメリカプリンストン大学上席研究員の真鍋淑郎さんらが選ばれました。真鍋さんは地球温暖化研究の先駆的存在で、1950年代末からアメリカに渡り、 コンピューターを用いて気候の変動を分析する研究分野を開拓しました。その後、二酸化炭素濃度の上昇が大気や海洋に及ぼす影響を世界に先駆けて研究し、現代の地球温暖化予測の枠組みを築きました。日本のノーベル物理学賞の受賞者は2015年の梶田隆明さん以来12人目です。真鍋さんは1958年に東京大学大学院を修了後、アメリカ海洋大気庁の研究員となりました。1997年に帰国し、当時の科学技術庁の温暖化研究チームに着任。2001年からは再びアメリカに渡り、現在はプリンストン大学上席研究員を務めています。
含めて最初に予測をしました。信頼できる予測です。大気中の二酸化炭素が2倍になれば、地表の温度は2度、摂氏2度上がると推定したのです。同じ頃にエドワード・ロレンツ氏はカオスについて説明しました。天候は混沌としている、急速に変わり、1週間で予測がつかなくなると言ったのです。ロレンツのカオスは気候のノイズなのでしょうか。急速に変わる天候とゆっくり変わる気候について、ブラウニアンモーションというのはアインシュタインの理論ですけれども、この時間によって状況が変わり、天候は何年もかけて変わると推定したのです。そしてシステム的なやり方で観測モデルを比べて特別な物理プロセスの指紋を割り出したのです。ガリレオは望遠鏡で宇宙を見ました。ジョルジオ・パリージは数学の内なる宇宙に目を向けました。そしてガラスのような素材が
cooling it under normal circumstances, it freezes into a periodic, well-ordered structure. However, if we freeze the liquid very rapidly, it becomes another body. We call it amorphous. It has attributes of both solid and liquid. We can understand the difference between these systems in daily life because we see them in glasses all the time. Glasses fracture like a solid and yet flow like a liquid. We can consider their energies, their energy landscapes. The periodic solid has a simple landscape. A particle in a bowl can only find one place to rest. In a glass, the landscape is complex and rugged. It's not clear where particles will reside. They are frustrated. Giorgio Parisi studied a magnetic version of a glass called a spin glass. Imagine that we can decorate this triangle with magnets. They can either have their north poles up, north poles down, or they can flip between north up and north down. Okay. However, we have the stricture that no two corners can have the same orientation. So when we place the third, it breaks the stricture, it breaks the rule. So another one must flip, which drives the flipping of another one, and so forth. Forever. The system is perpetually frustrated. Giorgio Parisi tamed this frustration, this complicated landscape, by building a deep physical and mathematical model which was so broad that it has impacted a vast range of fields far beyond spin glasses. From how granular materials pack, to neuroscience, to how we compute, to random lasers, and to emergent phenomenon far beyond what he envisioned in the 70s when he started this work.
Thank you very much, John. And it's now time for questions from you, ladies and gentlemen, in the audience. We hope to have one of our Nobel laureates with us, but I don't know if he is on yet. He is. Okay, very good. Professor Parisi, are you there?
Yes, I'm here.
Very good. Thank you for being with us. We are in the midst of the press conference.
Welcome. Thank you to you.
Okay, you have watched it. Very good. And now we have journalists from Sweden and all over the world, and I'm sure they would like to ask you some questions. Who would like to start? Thomas von Heine,
thank you.
Swedish Radio, Swedish TV.
Swedish Television Public Service. Congratulations, Professor.
Thank you.
I'm curious, your part of the prize seems a little bit different from the others, but there is a connection, I'm sure. Could you describe the connection between your half and the other half?
Well, during my work, I have studied many effects of disorder fluctuations. And for example, in about 40 years ago, I did introduce a new phenomenon, what is called stochastic resonance, together with Benzi, Sutera, and Vulpiani. That was supposed to give a qualitative description of the phenomenon of glaciation, of big glaciation, and give some qualitative explanation of the periodicity of qualitative and quantitative explanation of the periodicity of 100,000 years. So this idea, this was not directly related to spin glasses, but was part of my study of interplay between fluctuation in physical system.
Thank you.
Thank you. David Keaton over there.
From the Associated Press. Congratulations, Professor, on this award. This award comes just a few weeks before the COP26 kicks off in the United Kingdom. Do you have a message for world leaders that will be gathering to take decisions on ways to limit climate change, given the work that you've done, and today as a Nobel laureate, do you have a message for them?
Well, I think that it is urgent, it's very urgent that we take a very strong decision and we move a very strong pace, because we are in a situation where we can have negative, positive feedback, and that may accelerate the increase of temperature. So it's clear that for the future generation, we have to act now in a very fast way, and not with a strong delay.
Thank you. We have to act now. That was the message from Professor Parisi. More questions?
Yes, sir.
Yes, gentleman over there.
Yes, Daniel Ingmo, Express, and congratulations, Mr. Parisi. I would like to ask you,
thank you,
if you were expecting this award and how you reacted when you got the news.
Well, I was very happy. I mean, in some sense, I was not really expecting, but I knew that I have some chance, and so I kept the telephone near me. But I was expecting that phone call, was not expecting the phone call so early, but I was really very happy. I mean, I was not expecting, but I knew that there was some non-negligible possibility.
Right. Any more questions? Yes, Maria Gunther.
Yes, this is Maria Gunther from Dagens Nyheter. Congratulations to your prize. You have been working in many different fields in physics. What are you working on now?
Well, I'm working on, for the present moment, I work to understand better the physics of glasses. There are many questions that are not really understood. And also I'm doing some part of the time I'm following the pandemics of COVID, try to understand more precisely which is the situation, which is the correlation between different events and so on, because you see once that one has events, this data, big data, it is very important to follow with different techniques, with different viewpoints.
Yes, are there more questions? David Keaton has one more question, and then don't be shy, the rest of you. You have your chance now. David Keaton.
Thank you. David Keaton again from Associated Press. 2021 saw a great number of extreme weather events, from storms, floodings to heat waves. In your opinion, Professor, how important is it to truly understand weather patterns, and how can this understanding help prevent further catastrophes?
Look, there are many, many things that we do understand by weather, and also with the fact of the contribution of the other two, Sukuru, Manabe, Klaus Assmann. So this is very important. It's clear that there are still some details that we have to understand, because we have to understand the role of ocean and so on. But what is quite clear that the effect of climate changing is that more energy is emitted in the atmosphere, and if you have more energy in the atmosphere, the chance of extreme event is going to increase very strongly.
Thank you. Are there any more questions to Professor Parisi? Yes, one more question, please, lady over there.
Anneli Megner-Arn, TV4, congratulations on the prize. Yes, I wonder, when you find these spin glasses and how they fluctuate, is it a little bit like artificial intelligence? I mean, there are so many different ways in which they can form. So I wonder if you can shed some light on that, how you sort of get into the clue of this.
Well, the point is that glasses, a system like glasses, are very familiar in nature, and also also complex objects that we normally see, but we don't recognize as complex. So one has to make, from one side, some kind of general theory, and some specialize this theory to the particular object that you want to study.
Great. There we got some light through the spin glass. One more question. Yes, from Lundagård, students' newspaper in Lund University. Please.
Yes, thank you so much, and congratulations on the prize. As a student magazine, we're wondering, how will you celebrate this prize?
How do I celebrate? Well, I really had not the time to think about, because also with COVID restriction, we cannot have a very big celebration, but I think that I should do something, but I'm not really decided.
Well, Professor Parisi, when you can travel again, I'm sure the students in Lund will throw a great party for you.
Yes, we will.
Oh, yes, I believe so.
Thank you. We're glad to have you.
Any more questions to Professor Parisi? If not, thank you very much, Professor Parisi, for being with us at the press conference, and congratulations again to your Nobel Prize.
Okay, thank you so much. Goodbye.
Bye-bye. And now, are there any questions to the panel? Please, Ali.
Do you want me to ask in Swedish or English?
We can continue in English.
Okay. As been said, these are quite different prices. What is the link between them?
Hans?
So it is a divided prize. We should say that first. It is two pieces to this prize. But there is also, as you saw, it was an overreaching, description of the prize, which indicates that although these are two parts, two different prizes, it's divided into two, it's not one prize. But there is the common theme that has to do with disorder, that has to do with fluctuations, that has to do with how disorder and fluctuations together, if you understand it properly, can give rise to something that we can understand and something that we can predict. We can predict what is happening with the climate in the future if we know how to encode the chaotic weather, as Professor Wettlaufer told you about. And in the spin glasses, although it's a very complicated system, it's a hidden structure that you can discover if you analyze it in the correct way. And the correct way to analyze it was exactly what Professor Parisi discovered.
Any more questions? If there... Yes, Lunda går again.
Thank you. So with this prize, are the committee hoping to send a message to world leaders about the gravity of the climate crisis?
Well, the world leader that hasn't gotten the message yet, I'm not sure that they will get it because we are saying it. But it's a physics prize. And what we are saying is that the modeling of climate is solidly based in physical theory and well-known physics.
Yeah, you could say that the notion of global warming is resting on solid science. That's a message. John, you want to add?
I'll just emphasize that we have recognized here, I think, as you may have seen in the presentation, the real core of how climate has been understood and modeled from sort of its inception. And so our message is that we believe in physics, and that we're recognizing that emergent phenomena sometimes require you to look at all the individual complicated physical mechanisms and knit them together to make a prediction. And back to the question here, the overarching theme really does wed these two approaches. Giorgio Parisi's work looks at the underlying disorder and fluctuations and predicts emergent behavior. And the link between his work and Shukuro Manabe's work is the recognition by Klaus Hasselmann that fluctuations are key for predictability. And so we do not understand predictability unless we understand variability. And that's a key here.
Thank you so much.
Thank you. More questions? If there are no more questions to the panel, we close this part of the press conference, and now there will be opportunities for interviews with experts for those of you who have requested such. Thank you very much for your interest, and perhaps we'll meet again tomorrow. Thanks.